We have already discussed area of a parallelogram. Today we're going to talk about other types of quadrilaterals which we discussed previously this year and their areas. So we're going to focus on trapezoids, rhombuses or rhombi, and kites. So in order to talk about area of a trapezoid, we want to make sure we can identify the base and the height. So the height of a trapezoid is the perpendicular distance between its bases, just like the height of a parallelogram was the perpendicular distance between the bases. Okay, so in this trapezoid here, we have the bases. Remember, bases in a trapezoid must be parallel, and then the height is that perpendicular distance between them. When we get into kites and rhombi, we're going to have to pay attention to the diagonals. So I'll go over that quick. So the diagonals, remember, are the segments that join non-adjacent vertices. Same in a rhombus. So the diagonals join non-adjacent vertices. Okay. All right, moving back to trapezoid. So the area of a trapezoid is 1/2 the product of the height and the sum, oops, get my pink back, sum of the lengths of the bases. So it's 1/2 h times the quantity of base 1 plus base 2. Okay, so we'll go through one with numbers so it hopefully makes a little bit more sense. And again, this formula is on your formula sheet, I believe, if that helps at all. Okay, so base 1 and base 2 are your sides that are parallel. Your height is that perpendicular distance between those. So I'm going to plug all of these in. So we've got 1/2. My height is 5.8. My first base is 6, and my second base is 3.6. And it does not matter which one is base 1, which one is base 2. I'm just going based on how I highlighted it, so you can hopefully see what's going on. So I'm just going to take that entire thing, throw it into the calculator, and we should get approximately an area of 27.84 meters squared, or square meters. I'm actually using a specific unit this time because I was given the unit of meters. Last time we just used unit squared because we were not given specific units. All right, area of a rhombus is 1/2 the product of the length of its diagonals. So 1/2 D1, D2. Again, your diagonals are the segments that connect non-adjacent vertices. So sometimes it will be given inside the shape, and sometimes it'll be given outside the shape, whichever is a little bit easier to tell. The kite is the exact same formula. So area of a kite is 1/2 the product of the length of its diagonals. So again, D1, 1/2 D1, D2. And again, sometimes this information will be given inside the shape, sometimes it'll be given outside the shape. Okay, so let's look at some examples so you can kind of see what's going on. Rhombus PQRS represents one of the inlays on a guitar. Find the area of the inlay. So again, this is a rhombus. This is 1/2 D1, D2. Again, it does not matter which one is D1 and which one is D2. For a rhombus, let me see, this guy and this guy be your diagonals. Okay, so it's telling you that this top piece from Q to N is 9. Okay, so right here it says 9 millimeters. Notice that's pointing to just this part. because this is a rhombus, we know that the diagonals bisect each other. So I also know this needs to be 9. So that D1 I'm going to be plugging in is 18. Okay. For the second diagonal, I'm told that this is 12, and that is just the distance from P to N only, just this distance. So I need to double that to get this distance factored in as well. So D2 is actually going to be 24. So we're still using some of the properties of rhombi that we learned way back in chapter 9, I think it was. So if I do 1/2 times 18 times 24, that's going to give me an area of 216 millimeters squared. Okay. Got a few more examples here, so if you would like to pause the video and try them yourself and then come in, see how you did, feel free to do that. This first one is a trapezoid. So I know it's 1/2 times the height times the quantity of the sum of the bases. So let's see what I got here. I've got a base, I've got a base, I've got a height. So my base, my height, sorry, is 4. And then my bases are 8 and 6. This is a plus sign. Okay, so if I throw that all in the calculator, we should get an area of 28 square feet, or feet squared. The second one here is a kite. So it's 1/2 D1, D2. Okay, so this one, we are given some information. Whoops. Get my actual pen. There we go. 1/2 D1, D2. All right, so we're told that this right here is 14, and that is this whole thing here. Isn't the best way to mark it, but that is referring to that entire diagonal. The other diagonal is this right here, and that's what the 6 is referring to. So this diagram is not the best possible one. I apologize for that. So 1/2 times 14 times 6 will give us 42 inches squared. Okay, and then this last one here is a kite, or excuse me, a rhombus. Okay, so to get our diameters, we're given this much here is 30. That's what this information is. So that means the entire diagonal will be 60. And then looking down below, we're given this much here is 40. So that means the entire diagonal will be 80. So 1/2 times 60 times 80 should give us 2,400 meters squared. Okay, I know I really only addressed area. Perimeter, remember, is just around the outside. If you're ever asked for a perimeter, you just add up all the side lengths. Just throw that in there as a quick reminder. So let me know if you need anything. I hope you guys are doing well, and have a great day.